Okay, so in this problem, if you ask the question, is some part of the integrand the derivative of another part of the integrand, the answer will be a decisive no. We cannot use power rule here the way this is set up. So that most likely means it's going to be one of the U substitution problems. So let's try letting U be equal to the radicand. So let U equal x squared plus 2. So if U is equal to x squared plus 2, then U minus 2 would be equal to x squared, and the square root of U minus 2 would be equal to x. Now that is providing that x is a positive value. So then dx would be equal to 1/2 U minus 2 to a negative 1/2 du. So let's make these substitutions and see what happens with our integral. So replacing x with the square root of U minus 2, we will end up with U, the square root of U minus 2 cubed, and then the square root of U, and then du will be, or rather dx rather, would be 1/2 U minus 2 to the negative 1/2 du. Okay, so let's clean this up a bit. Okay, so first thing I did here was factor out the 1/2, since that was just a constant. The square root of U minus 2 is the same thing as U minus 2 to the 1/2, and that was cubed. The square root of U stayed as it was, although perhaps we should have rewritten that as U to the 1/2. We'll do that in the next step. And then U minus 2 to the negative 1/2. So let's continue kind of cleaning up this algebra a little bit because it's rather messy looking. We know from a law of exponents that when we raise this to the powers, U minus 2 raised to the 1/2, and then the whole thing is raised to a third, we actually multiply those exponents. So this will become U minus 2 to the 3/2, and then here we have U minus 2 to a negative 1/2, and then let's rewrite our square root of U now. That's U to the 1/2 du. Okay, this is starting to look a little better. So we're going to have 1/2. Now, when we multiply and the bases are the same with these two sets of parentheses, one of them is raised to a positive 3/2 and then the other one's raised to a negative 1/2, the base is the same, so therefore we add the exponents. So adding those exponents together, positive 3/2, negative 1/2, makes positive 2/2, which is 1. So we end up with just U minus 2 to the first power, which is just U minus 2. And then that's still times U to the 1/2. So U to the 1/2 can be distributed through the parentheses, so we end up with 1/2, and distributing there will make u to the 3/2 minus 2u to the 1/2. Now we use the power rule to continue into the next step. Okay, so by using our power rule, 3/2 plus 1 makes 5/2, so that'll give us 2/5 u to the 5/2 here. And minus 2 times, we have 1/2 plus 1 is 3/2, so that will give us the 2/3 u to the 3/2. So let's go ahead and simplify this a bit, and we can also factor. So if we rewrite these fractions using a common denominator, our common denominator would be 15. So this would be 6/15 u to the 5/2 minus 2 times 2 is 4 times 5 makes 20/15 u to the 3/2. Now it's easier to see what's in common. So in common here we will have 2/15 u to the 3/2, that's our GCF, and we're left with 3u minus 10. So now 1/2 times 2/15 will give us 1/15, and let's replace u with what u was originally equal to in this substitution. And I'll fix this. So u was equal to x squared plus 2. So we're going to have x squared plus 2 raised to the 3/2, and then 3 times x squared plus 2 minus 10. And by distributing the 3 through the x squared plus 2 inside those brackets and combining like terms, we can simplify the answer just a little bit more. So this would be 3x squared plus 6 minus 10, so that'll be 3x squared minus 4 when we combine the positive 6 and the negative 10. So that's as far as we need to go with that one.